Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about log-based protocols. First we will know about the logs, then we will know that how to implement the logs inside a schedule so that we can take advantage of the logs and use the logs to acquire a particular read and write one onto the schedule. Till now, we have described all the schedule like the serial schedule, the conflict serializable schedule, conflict equivalent schedule. But what happens if two of these operations are performed together in such a way that even if it in a serial schedule, we cannot perform the conflict serializability between these two? That means there are some conflicting operations on this one. Say suppose T1 is having a read and write combination of the operation, so as T2 as a part of the schedule S. Now the last write of this T1 is this read of this T2. So now we are reaching in a conflict 1 while we are having the serial schedule. So how this problem can be achieved? We need to introduce another mode that is known as a lock. That means when we are acquiring on a data item a lock, that means we can use a particular transaction at that point of time on that part of the data. Now locks can be two types. One is the shared lock, another is the exclusive lock. When we are having the shared lock on a particular data item Q. That means if Ti is getting a lock on this Q, say SQ, that means the Ty can have only read the Q. That means the data item can only be read by this transaction Ti. Now we can say that there is an exclusive lock on this Q, then we are mentioning that Ti is having an exclusive lock Q, so it can both read and write the data item Q. That means when a transaction is having a shared lock, it can only read the data. Now, when we have an exclusive lock on a particular data item, then we can both have read and write the lock. Now, after the unlock queue has been given or granted by that particular concurrency control manager, so the item cannot be locked anymore by that particular transaction, so that it has to acquire another lock on that data item later. Now we have to talk about that compatibility. Compatibility means that if say the Ti is acquiring an A lock mode on Q, now the Tj acquires the B lock mode on Q. Now if Ti has acquired an A lock mode and Ti wants an B mode on that Q, and it can be granted by the concurrency control manager, then we can say that A and B is compatible to each other. So if a first lock is acquired and the second lock is acquiring, so if it is acquired or granted an access, then they are compatible. So the compatible locks are absolutely necessary because sometimes there is one lock mode that is acquired by a transaction, and it is also possible that for another transaction to get that data item on another lock mode. So how we can build this? Let us build a compatibility matrix for this shared and exclusive lock. Say S denotes for this shared and X denotes for this exclusive lock. Now one TJ is having the shared mode lock on a particular data item Q. Now if Ti appears to have another shared mode lock, then we can say that is compatible, because it is also possible that on a particular data item, one transaction is reading the item, another transaction wants to read that data item. We can grant them the lock mode because the concurrency control manager sees it no dismally to have that concurrent transaction onto read modes on a single data item. Now say if TJ is having a shared data item and it is requiring an exclusive data item lock by Ti, it will be an false compatible, because if someone is having a shared mode, that means it can read the data item, so it is possible for the particular transaction to have right to that particular data item in a later way. Now if we grant an exclusive lock to another transaction for that data item, then now we are providing that both the data items on the transactions can write them. So we cannot let that happen, so now it will be a false. Now, if someone TJ is having a data item on an exclusive lock mode, then can it read and write both? Now, if another item on the transaction wants that share mode on that item, what happens here? Say that if a data item Q is being read by TJ and now it can write by TJ also, and later then it can again write by TJ. Now, in the midst of this transaction, if another transaction Tj is performed on an shared mode lock on the data item Q, so it can update or read maybe an intermediate updated value for the Q which Tj is performing. Say for the example that a bank transfer from one account to another account via another account. So this intermediate update the user doesn't want to know or should not know. So what will happen if TI is a user's transaction that wants a shared mode or the read mode log on data item Q, and if it is granted by the concurrency control manager, then it may read an intermediate updated value by TJ. So we cannot let any mode that is granted on a data item Q which is being granted an exclusive data item on another transaction. So it will be false. And there is no way that if a data item has an exclusive lock for transaction TJ, we cannot just give any exclusive lock mode on the transaction on a particular data item, because we do not want two transactions perform the right operations on the same data item simultaneously. So this is known as a compatibility matrix for the shared and exclusive lock mode. So one and only if a shared mode is acquired by some transaction, then another transaction can get the shared mode on that particular data item. So in this way, we can provide the compatibility by granting the access to the locking by the concurrency control manager. Now, how a lock that has been acquired by a particular transaction on a data item can be unacquired? We can use this unlock queue. We do not need to mention the particular mode of this locking while we are unlocking. We are saying that the lock mode that we are having on a particular data item, we are releasing the data item for that mode. So the unlock queue is having that queue item is being released and can now be acquired by another transaction in an appropriate lock mode. Now, if a transaction is having an X on the exclusive mode and wants another transaction to be in a shared mode or exclusive mode, then it needs to wait until and unless there is an unlock performed on that data item Q by that particular transaction. So we need to call the wait function for that purpose to wait for the particular transaction, wait until and unless it has been unlocked. Now let us consider two transactions by a banking and let us see that how locking and unlocking can be used in a locking protocol. First, we are having an exclusive lock on a data item B by this transaction T1. Then we can read and write both the data item Q. So after that, I have read the value of B, subtracted the value of B by 50, and finally updated the V. Now after updated the data item B, we are unlocking B. That means now B is being released. Now we are again acquiring an exclusive lock on data item A, read the value of A, add that 50 to the A, updated A and unlock A. Now again go to the another transaction T2. So now in the transaction T2, we have acquired a shared lock on SA, then read the value of A, unlock A, shared the value of the lock SB, read the value of B, unlock B. And finally, we have displayed A plus B. Now, if we perform these two transactions serially, that either T1 preceding T2. So now my account will have, that is A and B. First say it is 100 and it is 200. So now if we perform T1, T2, then it will update the B minus 50, that is 150. And finally the A plus 50, that is 150. So the result of T2 will be, now display A plus B, that is 300. Now if we perform T2, T1, then it is having the A and B as 100 plus 200. So the T2 results in 300. So this both are being serial and also conflict serializable, because we can just swap the orders of T1 and T2 to reach another serial schedule. We will produce by 300, 300 in both the cases. Now what happens if we both put these transactions in a schedule S in this manner within concurrent execution? That means some portions of T1 is has precedence with T2, another T1, then T2. Now let us say this example. Now we will also see that what is the part of the concurrence control manager in each of these portions of the transaction. So after the T1 has lock XB requirement, then the concurrency control manager just grant this exclusive lock on the data item B to the transaction T1. So after that, B has been unlocked by the updation of subtracting 50 to it. Now we will acquire an shared lock on transaction T2. Now the concurrency control manager will look for that we can acquire and lock on shared item B or not. Now see that B has been acquired a lock exclusive on this. After that it has released the lock. So now B is free. So the concurrency control manager can give the shared lock of B to T2. Now, if T1 performs an acquiring lock on an exclusive mode of A, then the concurrency control manager will look for that A has been shared on the T2. After that, it has been released. So now A can again be put to that exclusive lock by T1. So now the same transaction is being performed in a schedule S. So now we can see what is the problem. What will be the output of the schedule? First, the log XB is there. So the value of A and B is 100 and 200 respectively. So now B is being updated with 50. So now it will be 150. Now again for the T2, it has acquired the lock on SA. That is 100. It will read, unlock the item A. And again it will acquire and lock S on B, that is read 150 with B and then unlock B. Now if it includes a display statement here before this lock X, now it will display 250, that is 150 plus 100. So now T2 is showing a 250, which is an incorrect value because the correct value was 300. Now why this problem is happening? Because we have released this data item B too early, because we see that there isn't the purpose of the exclusive lock on data item B has finished. So we are unlocking the data item B. But it is not really required that after we have finished, immediately we are unlocking the data item B, so that we can lose the durability as well as the atomicity of the transaction. So now the durability result on this 250 is being not mentioned. Now we need to perform that unlock of B in certain way that the B will result in a consistent and durable one, not the inconsistent one. Now, if we just delay our unlocking until the transaction is being completed. So now remodify the transactions from T1 and T2 again. Now if we perform this one, see we have delayed this unlocking until and unless we have finished all the part of the transactions. Now what happens now, if we redo the same schedule, then we can see that the T through on this T1 is not giving as an inconsistent result. So we can make another type of scheduling out of this T1 and T2 being remodified with the unlocking delayed till the completion on the transaction. Now, when we are having this type of situation, then also an undesirable effect can be there. Let us look at the schedule once more. Now, let us see what happens in this schedule. First, we are acquiring an exclusive lock on this data item B. Now we are reading B, updating the value of B, and then update the B. Now we want to acquire a shared lock on data item A, read the item A. Now again we want to acquire a lock on Sheared, that is B. So we cannot have by the compatibility matrix that if a data item is being acquired on an exclusive lock by a transaction, then we cannot acquire another exclusive lock or the shared lock by another transaction. So now this one we cannot put. So this three we cannot have in this transaction. Now we are unlocking A, that is possible, and now we are unlocking B, that is also possible. Now we are having the lock X on A, having the read on A, updated A, and then finally write the updated value. After that, we can again put this unlock A and unlock B for this T1. So now we can see that we are not performing the T2 on a particular B site, and we are not having a consistent result based on these conditions. Now let us take a snippet on the part of this condition and see the situation more elaboratively. Now, if this situation arrives, what happens that we are having an exclusive lock on the data item B for the transaction T1. Now we are having updated on the B, that is fine. We are acquiring a shared lock on data item A. Now that B on the T2 requires a data item B to have a shared lock S. We cannot just grant them because T1 needs to wait for T2. So the T2 calls for an wait T1. That means until and unless T1 is being finished, T2 cannot proceed further. Now if T1 is happening to complete its execution, it now requires an exclusive lock on A, which is held by a shared lock by the transaction T2. So now T1 also requires that T2 to complete its operation. So now we are reaching in a condition which is called a deadlock. So now the schedule being in a deadlock state. When we reach a deadlock state, then we can say confirmly that one transaction is waiting for the other one, but the other one is conversely transversing on that particular transaction. So we do not want the deadlock situation to occur. So from now we can see that if we just eagerly unlock a particular situation on a data item too early, then we may result in an inconsistent state. If we do not acquire locks on a data item, we can result in an inconsistent state. But if we do not unlock a data item that is needed to acquire the lock on the other transaction, we will result in a deadlock situation. So now we need to define some protocol or some set of rules which we will know as a locking protocol to ensure that we are not reaching any of the conditions that we have described till now. Now to ensure the locking protocol, we will use the precedence graph that we have described in our previous videos that we will reach now, that the precedence we will reach and the legal one we will establish. So now to define the protocol on a locking rule, we are saying that there is a list of transactions T0, T1 to Tn in such a way that we can say Ti precedes Tj if and only if when there is that Ti is holding a lock on a data item on A mode, say on the data item Q, and Tj is holding a lock another mode in B on Q such that the compatibility between A and B is equals to false. So when we are reaching these conditions, then we are mentioning that we have condition with Ti precedes with Tj. So we do not want any Ti precedes with Tj in such a condition that is holding a lock that is later being holding with another lock in another transaction such that the transaction cannot be proceed with an compatibility matrix. Now, if Ti is precedes Tj, then we must guarantee that in all the schedule that you are following is Ti appearing before Tj. So we say that a schedule is legal if there is no transactions that appear Tj before Ti, and we can say that the locking protocol has been mentioned and maintained in both of these transactions. Now we take that legal serializable as the same way that if some serial schedule is produced a legal one, that is the legal schedule that we have described. If it comes with a serial schedule, then we call them a legal serializable schedule. Now we will talk about how to grant these locks. So whenever the transaction that is waiting for a particular data item to get locked and it cannot get because of the deadlock or because of the waiting, so then we can say that the transaction is being starved. So if a transaction is being starved and the concurrency control manager sees the transaction of the starvation period, then it will grant the transaction in both of the cases. If the transaction is acquiring a lock that is not being held with another previous transaction or the preceding's nature. Another is if it is holding a lock in the mode that is compatible through with any other transaction that is being preceding with it. So in these two of the cases, the grant will be there from the concurrency control manager to that particular transaction. Otherwise, the grants will be false. So till now we have discussed about the locks, granting of locks, and why we will acquire locks and unlocking the order of these locks. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.